Okay, number 1 says determine the measure of the 3 other angles in standard position between 0 and 360 that have a reference angle of 40. So if they have a reference angle of 40, that means you're going to have 40 here, 40 here, 40 here, and 40 here, right? So this is going to be 40. This is going to be what? 140. How'd you get that? Subtracted 40 from 180. This is going to be 220 because it's 180 plus 40. And this is going to be 320 because it's 360 minus 40. B. Now the reference angle is 72. So your reference angle and your angle in the first quadrant are the same, right? So 72. This one's going to be 180 minus 72, which is 108. And then 180 plus 72, so 252. Then 360 minus 72, what's that? C, if it's 88. So it's 88 here. This one's going to be 92. This one's going to be 180 plus 88, so 268. And then 360 minus 88 is what? And then D is 3 degrees. So this will be 3 degrees. This will be 180 minus 3, 177. This will be 357. Okay, complete the table, determine the measure of each angle in standard position given its reference angle. So it's a reference angle of 30 in quadrant 2. So reference angle of 30 in quadrant 2, so it's going to be a 30 is going to be here. So what's this angle going to actually be? 150. Then we have 45 in quadrant 3. So it's going to be 180 plus 45, which is 225. And then 60 in quadrant 4. It's going to be 360 minus 60, which is 300. Okay. The next one, you have to remember, if you see questions, this is what you have to do. And the trick to this one is it actually tells you it wants sine or cosine or tan. So off of your unit circle, you can pull sine, cosine, and tan off of it, correct? And if it says exact value, that's a scream that it might be very well, good chance, unit circle. Okay? So determine the exact value of sine. So this one here has the coordinate negative root 2 and 2 over negative or over root 2 and 2. That's off your unit circle, right? Remember cosine sine off the unit circle. X is always cosine, Y is sine. So I already have 2 answers. Cos of theta, or in this case, cos of 135 equals negative root 2 over 2. Sine of 135 equals root 2 over 2. And then tan, quiet please. Tan of 135 is root 2 over 2 divided by negative root 2 over 2. I mean, we divide two things that are exactly the same by a negative, you get negative 1. Yeah. Yeah. If you memorize every single radical option, yep, you can do that. But you already have your unit circle memorized, so why wouldn't you just copy the numbers off your unit circle? Now, 240. What's the coordinate at 240? It's going to be negative a half and negative root 3 over 2. So cos of 240 equals negative a half. Sine of 240 equals negative root 3 over 2. Tan of 240 equals negative root 3 over 2 divided by negative a half, which is negative root 3 over 2 times negative 2 over 1. The 2's cancel, the negatives cancel, and you're just left with root 3, which makes sense because tan in that quadrant is what? Positive. And that answer is positive. Yeah. (330) is the coordinate root 3 over 2 and negative a half. All right. So cos of 330 equals root 3 over 2. Sine of 330 equals negative a half. Tan of 330 equals negative a half, because those y divided by x, divided by root 3 over 2, which is negative a half times 2 over root 3. The 2's cancel, and I'm left with negative 1 over root 3. What's the catch? You have to rationalize it. So negative 1 over root 3 times root 3 equals negative root 3 over 3. You have to rationalize the denominator. Yeah. Okay. Number 4. Let's pay attention. You guys are going to do it. Number 4 says an angle in standard position with its terminal arm is in the stated quadrant. Determine the exact values for the other two primary trig ratios. Instantly, if I ask you for a trig ratio, or the two primary trig ratios, or whatever I ask you, if it's a trig ratio, you have to draw a triangle, use Pythagorean theorem to get through the third side, and then you can give a trig ratio. Every time I ask you for a trig ratio, that's going to be your steps. Whether I give you a coordinate and then ask you for a trig ratio, or I give you an actual ratio first and ask you for a trig ratio. You have to draw the triangle first, find the third side, and give me the trig ratio. It's not a hard question. You just have to know that when you see that I ask you for a trig ratio, that's what you need to do. If not, you're going to sit there and stare for a while. Okay? Or you're going to get 4 and 5 mixed up. They're totally different questions. Okay? 4 and 5 are totally different questions. So, I want you to try number 4 for now, please. Try number 4. So we have sine theta equals negative 3 over 5 in quadrant 3. And they want trig ratios. The moment I want trig ratios, I need to draw my triangle where it should be. So quadrant 3, sine your resume. So negative 3, 5. Use Pythagorean theorem. So x squared equals, and I'm going to instantly put a negative here because I know there's a negative, so I don't mess up and not make the x negative. That's why you need to draw it so that you get the right quadrant. X squared equals 5 squared minus negative 3 squared. So x squared equals 25 minus 9. X squared equals 16. X equals positive or negative when you take the square root, but in this case, it's negative 4 because it's in this quadrant. If you mess it up, you'll pick the wrong one and you won't get it right. Now it wants the other two trig ratios. So it gave us sine. Cos theta is cook extra rice. So negative 4 over 5. You drew it in this quadrant. This point is in this quadrant. That's a negative 4. It's just a point in quadrant 3. All x's and y's in quadrant 3 are negative. And then tan your x box. So negative 3 over negative 4, which happens to be 3 over 4. Positive, which makes sense because it's tan and it's in quadrant 3. B, cos theta 2 over 3 in quad 4. So we draw it in quadrant 4. Cook extra rice. So it's 2 and 3 and negative something. Because if I'm having any points in quadrant 4, y is negative. So y squared equals 3 squared minus 2 squared. Y squared equals 9 minus 4. Y squared equals 5. Square root, so you get plus or minus root 5, and in this case it's minus 5. Because I drew, minus root 5, sorry. Because I drew the triangle, which is important if I'm asking for trig ratios, that you draw the triangle so you don't get the wrong sign. Okay? Then, they gave me cos, so I do sine your resume. So it's me negative root 5 over 3, which is awesome, because I don't have to rationalize anything. And then tan is also awesome, because it's y over x. And I don't have to rationalize anything. And then C is tan what? What's C? Tan theta equals what? 5 over, pardon? And it's in quadrant what? So x is negative in this quadrant. Tan your x box. This question, I know people are going to get wrong because they're not going to draw it first off and then be like, I don't need to draw it. R is positive. However, can y be negative here? No, what's negative here? The x. Can I move that negative sign around? Absolutely. So it's going to be negative 12, 5, solve for r. R squared equals 5 squared plus negative 12 squared. R squared equals 25 plus 144. R squared equals 169. R equals plus or minus 13, and in this case it's positive because it's R. Always. That's why I said the moment they're asking you for a trig ratio, you need to draw that triangle. That needs to be the very first thing you do. So you draw a triangle first, use Pythagorean theorem, give me the trig ratio. Because when you take the square root of 169, you get plus or minus 13. Because whenever you take the square root of a number, you get positive, negative, that number. So, sine theta equals what? No. Whenever you take the square root of any number, you get plus or minus. Okay? Then you draw it in a quadrant for a reason. Yeah. So you what? Yes. No. So if you take the square, can you guys stop? Because he really doesn't understand just based on something really simple. So let's let him understand. So it's because you know the plus or minus thing, but the reason why you pick which sign you do is based on where you draw it. And R is always positive. So technically, if you did forget the plus or minus sign on the R, you'd be fine. But that's not mathematically sound. So on an R, it's always going to be positive, but you have to draw the triangle. If you don't draw the triangle, except for with R, because you know R will always be positive, but if you don't draw the triangle, then you maybe would have made Y be negative and X be, you know what I mean? So you catch yourself after you draw the triangle. So the very first thing you should do when you get a sine or a cos or a tan of a trig ratio is what I've said 8,000 times. Draw the triangle. Wow, that was one person who answered me. Draw the triangle. Then 2, solve for the other side. And then 3, state the trig ratios. That's scaring me. Just tomorrow. Yeah. It's a distance. It's a radius. Can't have a negative distance. Yeah. No, they'll say radius. They'll say radius. But we wouldn't do this in a word problem anyways. No. Yeah, but they're like the sine law and cosine law most of the time. Okay. So cos is negative 12 over 13. All right. So 5 looks a heck of a lot like 4 because it says sine theta equals something. And if you look at 4, it says sine theta equals something. You have to be able to spot that they're different and asking totally different things. Okay? So 4 is asking us for the trig ratio. So that's asking us for SOHCAHTOA or sign your resume, cook extra rice, can your Xbox. Yes? Now 5, on the other hand, says, okay, 5 on the other hand says solve each equation between 0 and 360. So if you give me a trig ratio, are you right? No, you wouldn't even, you'd be guessing it's what trig ratio I'd want. Because I didn't ask for one. I don't want one. Don't give me one. Okay? So what we do in this case is when you're given the previous question, you draw the triangle first. You find the third side. You give me the trig ratio. We agree? When you're given number 5 and I ask you to solve for an angle, so this one is sine theta equals 0, 7.7760. And I'm actually asking for an angle this time, right? I'm asking for an angle, correct? The very first thing you do is you find the reference angle. Do you remember these steps? So first step, find reference angle. Oh, go back in your notes. Theta equals sine neg 1 of 0.7760. No. You asked me specifically on this question. You said, if I just punch it in, I get 120 degrees. Can I not just use that and get the reference angle from that and do it? I distinctly remember you asking that question. Yeah. So sine negative 1, you always take the positive. So even if this was negative 0.7760, you would still do the positive. You never use the negative, okay? What mode do we need to be in? Thank you. Ha! That was unison. You finally all actually answered something. But in grade 12, that's not true anymore. Yeah. Okay, so what is this going to be? Yeah. What? I'm so not posting this recording, just saying. Okay, what are we going to get for the reference angle? 51.1, or is it just 51? 50.89? Okay. Now that is the reference angle. Step 2, use cast. Oh, please, you cannot tell me you don't know what cast is. Like, if you tell me I didn't teach that, I'm going to be like, do some of that. Sure. Okay. So we use our sign of the original question to decide where our arms are. So this is sign what? Sign positive 0.7760. So I'm going to go in the positive quadrants for sign, which is here and here. 3, use your reference angle to get the answers. Okay. So the answer to this one is 50.89 because the reference angle is the same in that quadrant. This one is going to be what? 129 point. Really round to whatever I ask you to round to. You would only round to whatever I ask you to round to, and I only round at the end. Okay. B. Cos theta. For people who aren't sure what you're doing, this is really shocking me right now. Based on the fact that I asked questions and you guys told me I've never taught it before. So I'm going to say that you don't know what I'm doing. B. Cos theta equals negative 0.8. Okay, now pretend I actually restrict this one's domain between 180 and 360. Yeah. So we treat it exactly the same. We do all the exact same steps, and then we just pick the answers that are between 180 and 360. That's it. Nothing hard, nothing crazy, just this. So step 1, find your reference angle. So theta equals cos neg 1 of what? What do I use? Positive 0.8090. Then theta equals what? Reference theta equals what? What'd you get? Was that rounded? Okay. So 36. Then step 2. Use cast. So where am I doing this? Not bottom right and top right. It's cos negative. So I use the positive to get my reference angle, but I can't ignore the fact that the actual answers are in the negative quadrants. So it's going to be here and here. So you do 180 minus 36, which is 134. Because it's negative. It's negative. $144? Yeah. Thank you. I'm just cutting my losses on that one. And then this would be 180, 216. Yeah. Yeah. You just, yes, but you really just pick the letters that aren't cos letters. T and F. Cos cast tells you where the positives are. Okay, but what are you going to do with tan?
I don't know how I'm going to figure that out. Yeah. How do you know if it goes straight or if it goes
That's why we use cast. Tan is positive here and here. So it's negative here and here. So if my original question is like tan theta equals negative something, then you're going to do these two quadrants. If my original question is tan theta equals positive something, then you're going to use these two quadrants. That's it. Like, don't overthink this. You're overthinking it. Literally, if the original question is negative, you go to where those letters aren't. If the original is positive, you'll go to where those letters are with the alls, right? That's it. Like, it's not tricky. Don't try and, like... And in 30, it comes up a lot. So it's important to know it. Okay? Now, the catch here is... This one's out. Why is that one out? Not between 180 and 360. Okay. I asked you between 180 and 360. 144 is not between 180 and 360. C is tan theta equals negative 0.9004. Shh. Try this one out, please. Yeah, I can. I'm going to do 0 and 180. Yeah. Horrendousness. So please try the question. So your reference theta, please study this at night, you guys, because just because it's in there right now doesn't mean by tomorrow it hasn't left the building, because I taught this before and you're acting like I haven't. So go home and study it. Tan neg 1 of 0.9004. What do you get, 42? Is that what someone told me? Then you have to go where tan is negative. Tan is negative here and here with reference angles of 42. So this is 180 minus 42, which is 138. And then 180 or 360 minus 42, which is 318. And this one doesn't work. And this is the way that I can make it so you can give me one answer in a numeric response box. Right? I could, but... Like on a SOHCAHTOA, like on sine law or cosine law, then you wouldn't round. For this, but not for sine law and cosine law. But for this, yes. Okay, unless I ask for the nearest tenth or something, then you'd have to do what I asked for. Yeah. Okay. 2 shifts or 1600. I'm going to do this on a separate board. And I want to finish this before the end of class, so please pay attention. Okay, I need my board erasers back who all stole them.
Yours is right there for you.
So the one type of question we're going to go through now, it's half-life doubling, tripling time. So if you see half-life doubling or tripling anywhere in the question, you're going to do this type of question. Okay? The formula I always use is F equals I R to the T over P. Now, I don't care what formula, you're rarely given a formula on your diploma, but if you are, I don't even care what the formula is. If it's one of these type of questions that we went over for, I just use my formula because it's just easier. The compound interest formula that sometimes they put on is like A's and P's, but then it's like a whole bunch of different letters that mean final and initial. So I always just stick to F whenever it's a final amount and I when it's initial amount, so that whenever we move from one question to the next question, F is always final, I is always initial, not A is final and P is initial. Like, why are we switching letters? Because they want accumulated amount in principal, but it's final and initial. So I just label them F's and I's. So if you get to the diploma and it's an A and a P, it doesn't matter. Whatever's in this spot here is always your initial amount, and whatever's back here is always your final. Now the reason why that is if I plugged in any values here, this here will be always your initial amount because it's your A value. It's where you start, okay? So F is final. I went to go put F, but I didn't. F equals, that's just terrible. I can't even keep that. All right. F equals final. I equals initial. R is the rate. And for these half-life doubling, tripling ones, the rate is always the same depending on what it gives you. So if it gives you half-life, R equals a half, 4.5. If it gives you doubling, it doubles every whatever, it's 2. And tripling, it's 3. Remember I was like dodecadododing yesterday, I said that, which made no sense? It'd be 10, but I don't know what that is. But anyways, and that's just the rate that it's going up by, right? Or down by. So we went over yesterday on our graphs, whenever B was like a third or a half, when it was that fraction between 0 and 1, what happened? The graph was decreasing, right? When we put in that like y equals a third x, it was decreasing. But when we put in 2 or 3 or 10 or 5.25 for the b to the x, it was increasing, correct? So you can tell immediately by an equation if the graph is exponentially increasing or appreciating or exponentially decreasing, right? Based on your R value. So this half-life, well, it's declining, right? If you start with a value and you're halving it, it's going to decrease or depreciate. And if it's 2 or 3, it's going to increase or appreciate, right? So based on your little b value, you can tell whether it's increasing or decreasing. So if you're like, my final is, or you get 2 values, let's say, and one of them is 1 and one of them is 1,000, which is final and which is initial, well, it depends on what your R is. If your R is a half, it's going to get smaller. So the 1 would be your final and the 1,000 would be your initial. But if it's a 2 or a 3, it's going to get larger, right? So your 1 would be your initial and your 2,000 or 3,000 would be your final because it's getting bigger, right? So they should make sense. It shouldn't be like guessing which one's going where, okay? So T and P, T is the time to reach final. P is the period of your rate. The way I remember it is this one, if I had to draw an arrow through here, I'd be like drawing this crazy arrow, be cutting through some letters. So T just goes to F, P goes to here. So T is time to reach final. P is the period. So how long to half, double, triple. P always comes after the word doubling, tripling, or half. So if it says it doubles every 10 minutes, that would be P. If it triples every 5 minutes, that would be P. If it says how long does it take to double, they're asking you to find P. How long does it take to triple? They're asking you to find P. And often they make you find T or P because that's how you'd have to solve for exponential. That's what they're doing, right? They're making you find that. If not, you could just fill in values and divide and get your F's and your I's. So often they are leaving out T and P. Okay? And if it says the bacteria grows to 1,000 in 5 hours, 1,000 would be your final. In 5 hours would be the time to reach final. It would go in your T. Okay? Make sense? So I always say you know if you got P or not based on the fact if it goes, it doubles every blah, or if it asks you how long to double. That's your p-value. And then t is how long it takes to reach final or initial. Okay? So let's go through what we have. A lab tech placed a bacterial cell. What does that mean? Your initial is 1. Most people miss that because it's not a number, right? They catch the 5 a.m. part, but they miss the bacterial cell. So on my I is 1. And remember, in order to solve any of these equations, you can only be missing one variable, just like in any other science that you do. In order to solve an equation, you need to be only missing one. If you're missing 2 variables, you can't solve, right? Into a vial at 5 a.m. This is important if it asks me like the time it takes to reach the final, right? You'd get your time in minutes or whatever it is, in minutes, and then you'd add it to your 5 a.m. and you could tell me the actual time. But if they don't ask me for the time it takes, then that 5 a.m. is just extra. The cell divides in such a way that the number of cells doubles, and it's a cell, so we're not going to be halving the cell. Like, that doesn't really make sense. Radioactive material, half-life, right? Cells, bacteria, all that stuff is always like doubling, tripling, getting bigger. So it doubles. So what's that mean? Your rate is 2. Every 4 minutes. T or P? P is 4. And I know that because it came after the word doubling. It doubles every 4. That's the period, how long it takes to double, triple, half. Okay? The hardest part for this is people figuring out which is T and P. Because people will just guess. Guessing is not good. You do not want to guess because you have a 50-50 guess, and that is scary. Okay? Now it says, how long does it take for it to divide to, for the cells to divide to produce 4,096 cells? What's that? That's my final. And does it make sense that I'm missing my T? Yes, because it's asking me how long it takes to reach the final amount, right? Okay. So we have 4,096 as my final, equals my initial, which is 1. My rate is 2. And then to T, which I don't know, over 4. Now, in this case, because my initial is just 1, if I don't divide it over, it's not a big deal. But what I suggest to you always, especially if you're going to be plugging this into your calculator or solving it, you always divide your initial over. If you know your final and your initial, you will always divide your initial over because it'll make your final smaller, usually, right? In this case, it's a 1. If I divide a 1 over, it's not going to do diddly squat, but that's okay. We're going to just show that we do it. So that's my first suggestion to you always, which didn't do anything. I know, sorry, but that's okay. Okay. Now, we always check, can we make common base? Is 4,096 a base of 2? Is 2 to the something 4,096? What is it? 12? If it wasn't common base, could I just go y1, y2? Yes, and we're going to go through that as well because, trust me, the place where people actually are really bad at the y1, y2 is they cannot get a window to see it. So we'll go through because it's very easy to get a window to see actually once you think about it. So it's 2 to the 12 equals 2 to the t over 4. So what we actually have is 12 equals t over 4 multiplied by 4. T equals 48 minutes. Now we ask ourselves, does that actually make sense, 48 minutes? Yeah. If you had accidentally divided, you would say 3 minutes. Does that make sense? It doubles every 4. I need to get to 4,096. Does 3 minutes make sense? No. So you have to think, does it make sense? Okay. Now let's go back to here and try and put in our calculator. So this would be y1. This would be y2. Now remember, you're putting this fraction in brackets. Unless you have the calculator where it pops the fraction up. If it pops the fraction up, you can just go x divided by 4. Instead of a t, you'd put an x, right? Because it says xt theta n. So x can represent any variable. That's what that little button means. So you're going to go 4,096 in y1. And then in y2, you're going to go 2 to the exponent t divided by 4. If you have a calculator where your exponent doesn't pop up, you have to make sure to put this in brackets. Okay, so if your calculator's exponent doesn't pop up, that's fine, but you have to go t divided by 4 in brackets. If not, your calculator is going to think you're going t or 2 to the exponent t, and then taking that answer and dividing it by 4. That's what it thinks you're doing. It's not what you want it to think you're doing. So if you have a calculator that doesn't pop up, put your fraction in brackets. If you have a calculator that does pop up and you want extra feeling better about yourself, put it in brackets. It's not going to hurt it either way. So I always just put fractions in brackets no matter what, because then I know that the calculator knows it's a fraction, right? Okay. Now when people press Zoom 6, press Zoom 6. You get your negative 10, 10 window, negative 10, 10 window, right? And then they're like, I need to find where they intersect, but I only see one thing. Okay? Why do you only see one thing? Because this one is y equals 4,096, and your window is at 10. So like way up in the sky, there's a horizontal line above your calculator that's at 4,096. You're just not seeing it. So your y max needs to be at least this. So that's why I said if my initial is something else, it can knock this down. That makes me happier, right? Then I don't have to make my y max this big. So you're going to have to make your y max be at least 4,096 or you're not seeing that line. So like 40, 100, whatever. Now you have to be able to see it. If you can't see where it intersects, your calculator can't calculate it. Can it see the crossing? Is it crossing? So this one crosses at 48, right? So if you think about it, if your x max is 10, you're not seeing where it crosses. So often you have to make your x max bigger is the catch. I usually don't make anything else bigger, just my x max. So your x max is going to have to be at least 50 because you're finding x equals 48, right? So at this point, you're going to have your y max be over 4,096 and your x max be over 50. You don't know that though because you haven't found it. So I would do 50 or 100. Like I don't go like 50 and then a million. That's overkill. Do like 50, 100, maybe jump to 1,000, but like don't like go a million right after that because most people do. They're like, well, if it's not 1,000, it must be a million. I will do that. Okay. Then second trace 5. Enter, enter, enter. Which value do we care about? And it's at 48. Could I have done this? Could I have set this equal to 0 and go 2 to the power of t minus, or t divided by 48 minus 4,096? Yeah, I could. If I set it equal to 0, what are you finding then? X-intercepts. So it just depends. And why are you finding x-intercepts? Because y1 is 0 and y2 is the other equation. Where are they intersecting? The x-axis. Yeah. Okay? So we're going to look at number 3. Number 3 is like number 2, but there's a little twist, per usual. Okay. So number 3 says, what is the half-life? So I know I'm instantly using this formula because it has half-life, right? So that's what? Yeah. Of plutonium-232. Do you know how many people I have putting initial as value as 232? No, plutonium-232 is a thing. It's an isotope or something, isn't it? We're going to call it that. And if someone watches this and says it's not, meh, I don't care. So it's a something that is, it's an isotope of plutonium, isn't it? Like there's just plain plutonium and it's an isotope. Yeah. Don't ask me any other questions other than that. That's all I know. So what I tell people, if they really have that fever to put 232 somewhere, just be like, good, it's plutonium of some sort. Like I don't care. Cross it out. Cause the madness to go away. I don't really care. Just don't use 232 somewhere. It is not used in the question. It is a type of plutonium. Okay, so what is the half-life of plutonium? What are they asking us to find? And right off the bat, I know what they're asking me to find. What are they asking me to find? What? Period. P. What is the half-life of plutonium? They're asking you how long does it take to half. They're asking me to find P. If I know that right off the bat, I know I need to fill in all the rest of the letters. Okay? If, and this is the catch, what is the half-life of plutonium if in 204 minutes, so that's my time, it doesn't say it halves in 204 minutes, right? It's asking you what the half-life is. So what is it? If in 204 minutes, a sample decayed to 1/64th of its original mass, and this is where people fall apart because they're like, what is the initial? You didn't tell me. You didn't even tell me the final. You just told me it decayed to 1/64th. Does it matter what the initial is? No. You could make it be 1 bajillion. because that exists. And then you could just find 1/64th of that and tell me the final, right? I would suggest that'd be bad. So I would pick something that's easy. So I either pick 100, which makes people's hearts sing a little better because then they get 164, or you could pick 1, because what's 1/64th of 1? 1/64th. If you do 100, it's 64. Now pay attention. If you do 100, it would be 64, correct? If you do 100, what's 1/64th of 100? Is it not a 64? Am I wrong? 6,400. Yes, that's it. I'm like, it needs to be 6,400? What's 100 times 1 over 64? Okay, thank you. The reason why I know it needs to be not 64 is because if I did 64 divided by 100, it would be 64 over 100, and I needed to be 1 over 64, and that was not working. So I was like, it is not right. So what is it as a, what is it, 0.5, is it like terminated to there? Don't do this, just pay attention. And then, so if I picked 100, it's a lot more work, obviously. And then I divide by 100, and what's that divided by 100? It would be 1 over 64. And the initial would be 1 now. So why are we making our initial anything other than 1? We're just making our lives harder, okay? That's my point. So if I have a choice, I will always pick my initial to be 1. Because this wasn't fun. I even said 64, which was completely incorrect, right? Now you keep decimals and divide them by 100, and you get 1 over 64, and you're back to where you were if you picked 1. So this is not a good decision. So if I have a choice, a sample decayed to 1/64th of its original mass, you can pick any original mass, do 1/64th of it, get it as your final, divide them out, and you'll have 1/64th. Or you can make your initial be 1, and then your final is 1 over 64, and we've done all of our math, and I didn't have to do any math. Okay? Does that make sense? Because that's where I lose people. They're like, I need to know what the initial is. You can make it be whatever you want. When you divide it over, it'll be 1/64th. Okay? So we have 1 over 64 equals 1, bracket, 1/2 to the 204 over p. Divide the 1 over, and I have 1 over 64 equals 1/2 to the 204 over p. Now, why am I showing that step? Because it's not often 1. It's your initial is often something else, right? It just happened to be 1 in both these cases. Now, I can make a common base for both of these, for 1/64th and 1/2. 1/64th is 1/2 to the 6. All I do is 2 to the what is 64? Oh, 6. So it's 1/2 to the 6. Then I get 6 equals 204 over p. Bring the p up. So I have 6p equals 204. And divide by 6. P equals how many minutes? 34. Remind me tomorrow to hand those out, because then you would have wrote 34 and I would have seen it and it would have been good. And the 5 would have if it was a written response, which you don't have, but if I give you a written response, then yeah, because you'd be wrong. The catch also here, and I've never seen it where they give you different units, but these have to be in the same unit. So if like this is 204 minutes, then we know that p is in minutes. Okay, so if one was in hours and one was in minutes, you'd actually have to convert them, because T and P have to be in the same units. So if T and P are not in the same units, you'd have to convert one. So if like T was in hours and P was in minutes, you'd either have to do minutes or hours. Okay?